So today we will be converting primal canonical form to dual canonical form. So first step is to determine how many constraints we have in our primal form. So the number of constraints in primal will equal to number of variables in the dual. So in this canonical form, how many constraints do we have? 1, 2, and 3. So we have 3 constraints. So our dual objective function will have 3 variables. So the first step is the minimization function of the dual form will have 3 variables. So g of y1, y2, and y3. Now the objective function, we will determine its weights from these values. The right-hand side values, these values will be the weights. Now the second step is the right-hand side values of the primal constraints will become the weights of the dual objective variables, which are these values. So second step is, so 20 will be the weight for y1, then 30 y2, and then 25 y3. Now the third step is make a matrix table of the primal LP constraints, only the left-hand side of the inequality, then take a transpose of it, meaning that all these values here, the 1 here, the 2, this 2, this 2, this one right here, and this one right here, the 1 here, we have to make a matrix of this. So second step is make a matrix. So 1, 2, 2, 2, and then 2, 1, and then we take the transpose of this matrix. So we invert it. So these two will become the first column. This row will become the second column. And this last row will become the third column. Okay, now the last step is, so this new transpose will be the new constraint set for the dual LP with y variables. So let's write that down. So it will be 1 y1, 1 y1, plus 2 y2, plus 2 y2, plus 2 y2, plus 2 y3. And then the second constraint is 2y1 plus 2y2 plus 1y3. Now what comes on the right hand side? So we flip the inequality sign. So here we had less than or equal to. Here we'll have greater than or equal to. And the right hand side will be the weights of the primal objective function, meaning these values, this 4 and this 3. So 4 and then 3. So these are our new constraints, constraint 1 and constraint 2. So this is how we convert a primal to dual. So let's write that down more neatly. So this is our final dual LP in canonical form.